Hang on, let me put it. Can you explain a little bit what this product is about? What Exosystem is?
Let me just explain it for you. So I'm the in-sun row of Exosystems.
Yes.
And so what it can do is basically using the artificial intelligence, it's going to be diagnosing the sarcopenia or any kind of muscular disorders, neuromuscular disorders. So let's say if you had undergone neuronic surgery, such as after stroke or so on,
Yep.
you lose a lot of muscle.
Yes.
Muscle degeneration happens. You have to stay in bed so long. Lose a muscle. So doctors has to diagnose how much muscle has been lost and how much level of muscle functionality you have. So what you do is just like this, you attach it on the multiple part of the body, and then let me just show you right here. So as you can see, what I'm doing is
Yep.
so
it measures
there's
the
nothing,
EMG.
and if I squeeze the muscle, it's going to come out. So if I squeeze it, the EMG pops up. If I don't, it
Yeah.
doesn't.
Yeah.
So what it's doing is it's actually measuring your muscle status, as well as you can see, it's the electrical intervention, which means if I squeeze the muscle, electrical intensity is going to be coming in and out. So which means this device can detect the onset and offset of your muscle excitation, as well as it can actually help you rehabilitate based on your muscle response, not by any other muscle, let's say physical therapists has to help you for these kind of things before, but
Right.
nowadays, even without it, you can just attach it. It will automatically recognize your muscle excitation and your muscle status also.
So can it tell between different muscle type, or it's just whatever muscle you're attaching it to?
So right now, we're developing more on distinguishing the muscle types, let's say type 1 and 2, and also different part of the body, but that's for the next step. For now, we have to designate which part of the muscle you have attached. Let's say quadriceps, you have to select quadriceps. But everything else, if you attach it in a certain part of the muscle, it will detect quality and your average level of your certain age group, the data, among the data we have, and so on.
So what is this intended for? Correcting? What kind of problems is it?
So there's two. So for the medical sides,
Yep.
so doctors would want to know how these patients are doing at home and so on. So it'll help you the remote patient monitoring, as well as solving the compliance issues. And for the pharmaceutical sides, so it will help you reduce the cost of clinical trials by seeing the muscle status or any kind of symptoms based on the dosage that has been applied.
Ah, yes.
So it can also remotely gather the information. So nowadays, phase 4, decentralized clinical trial is prevalent, which costs a lot because you have to gather all the data from remotely, and this will actually help you how much your muscle functionality is. And also, that was for the medical side. If we move on to the fitness side, general wellness side, like personal trainers in the gym would actually help you to see how much muscle excitation you have. Let's say you're the personal trainer and you let me do the squats like this, and it will tell you how much muscle excitation you have, and also you can see the muscle balance on each part of the body.
I see.
And all those things combined together.
So you're serving 3 different markets, and the medical market and the clinical trial market, those things are high end, so the cost is not an issue.
Yes.
But when you're going into the consumer market, how do you balance the cost issue in the consumer space?
So we're not going to be saving the cost, actually. We're actually going to be justifying more fees for the personal training. So conventionally, personal trainers, when they have their experience, they have a good body, so they'll teach you how you should contract your muscle and how to build up the muscle. But more and more, these personal trainers would want to add more values to their teachings. So they can actually add these kind of scientific. So nowadays they have a lot of joint angle analysis systems,
Yes.
like video cameras, so they can see how your muscle is moving and so on. But if we put this on, it will actually tell the quality of the muscle itself, how much contraction you're doing and how well you're doing. So if you, even though your joint angle moves the same, that doesn't justify the muscle excitation of certain part of the body. So it will actually help the user
Interesting.
and the personal trainer to understand not just the physical movement, external movement, but also the muscle excitation itself.
So I assume you've studied the personal trainer market space. What are you thinking of pricing for that space?
So that's something we want to work on. So just last year, we also come to the CES without the Innovation Award, but lots of the gym owners, personal trainers came to us, also physical therapists came to us to see these kind of functionality is available. So these ideas from the market was not from our own head, but from theirs.
I see.
So we also got the demands from them, and we would also like to apply them, starting from the POC in Korea, where we're based on, and we would like to apply more POC abroad in
So
US.
it sounds like you haven't determined the pricing yet for them.
But there are also some options, of course, analysis and giving these kind of a scanning software based is more value. So we're going to be spreading these kind of hardware in a really cheap price, and then do a subscription model and so on. So these are just an idea.
Okay.
So we can move on based on the gym owners' demands and so on.
That's exciting. So did you know what features kind of led the CES to give you an innovation award? What did they find to be significant?
So which one? So it's called, we got it on the digital health side. So what we focused on was the AI-based analysis of the neuromuscular status.
Oh.
So conventionally, they had to walk around or do the grip tests. Conventionally, physical therapists had to see more of a qualitative data. But what we're doing is actually we're getting the signal from the motor neuron itself.
Yes.
So we're based on more from the source of this muscle signal, not from the external outcome, but from the source of the origin of this muscle movement and muscle quality. So that's what we focused on, and I think they.
Well, congratulations on the CES Innovation Award. Good luck to you.
Thank you very much.